just want to show you some amazing thing here. I hook up this motor guide, 70 pounds, foot control, trolling motor, okay? It's a motor guide, 70 pounds, foot control, trolling motor. As you can see here, it says Motor Guide Pro Series, and it's a 70 pounds thrust. Made the control speed to 5th gear. It's the 5th gear, so it's on 5th instead of neutral. Right now I'm going to turn this dial. Okay, you hear that ding? You can see that motor slowly turning. Now it's 0.2 amps. 0.2 amps with 12.71 volts. And now I speed up. Blades turning. And you see, I don't hear any noise from this PWM. Now let me increase the speed by turning this radio button here. And that's drawing 0.74 amps. Okay? 0.75 amps. Let me increase this to maximum. Right now it's 1 amps. I don't see anything from the PWM, but I see a huge humming noise. Motor guy, 70 pounds, turning its blades. And you can see right now it's drawing about 1.5 amps. Okay, so it's drawing 1.57 amps. 1.5 amps. I guess it's you see that light on, meaning the motor is the PWM is functioning. And my PWM positive red wire is clamping to the positive of my motor guide. My negative from the PWM, that black wire, is clamping to the negative end of this motor guide. Negative. It's 1.6 amps. 1.6 amps. Of course, this is a 24 volts. So in a second, I'm going to connect another battery to make it 24 volts. Right now, it's only 12 volts. I know this is not good for the motor guide, 24 volts. It's designed for the 24 volts, but I think it, for the experiment purposes, for our purposes, should be fine, because I'm just doing this for a moment. Let me shut it off. It's increasing to 1.62 amps now. Let me shut it off, because I want to connect to 24 volts and see how many amps at its maximum speed this motor is going to draw. How many currents, how many DC amps this motor is going to draw. So we'll be back in a second when I connect this another battery, 12 volts battery, to this. As you can see, this is a Marine RV Pro Deep Cycle 29-hour amp. It has cranking motor power of cranking motor power of 675, and cranking 840. Reserve capacity is 410. Anyway, that's my 12 volt battery. Testing on the 24 volts motor guide 70 pounds. But you know what? I'm going to connect the 24 volts. Okay, this is first gear, no PWM. First gear, no PWM. No PWM. Just hooking up the motor to the battery and the display. It's drawing 1.25 amps and it's burning 15.8 watts. Now it's up to 16.2 watts, 1.2, 1.3 amps, and 16.4 watts. Okay, so this is the first gear. from my motor guide. 1.29 amps, burning 6.3 watts, 16.3 watts, okay? 16.3 watts, 1.29 amps, 1.3. I'm not sure if this, well, I think this is right. It's 15.7 watts, 1.25 amps. And this is the 1.31 amps, 16.5, 16.7 watts, second gear, okay? I'm doing the trolling motor right now. This is the second gear, 1.34 amps, 16.8 watts, 1.34 amps, 16.8 watts, 16.9 watts, 17 watts, 1.36 amp, 1.37 amps, 17 watts. You know, it's amazing how little watts this big motor is burning on second gear. This is the third gear, which is pulling out 1.4 amps, 17.8 watts. And amazingly, I'm only hooking up 12 volts, by the way. I'm not hooking up the 24 volts as I did earlier. Anyway, 12.6 volts, 1.43 volts, 1.43 amps, 18 watts. This is the third gear. 1.45, 18 watts. This is the fourth gear. Pulling only 1.45 amps, and it's 18 watts, burning 17.8 watts, 1.42 amps. This is the fourth gear. Of course, I'm operating the motor in the air without load, not in the water, okay? So it's pulling up 1.41 amps, 17.6 watts, burning, and 1.41 amps, 17.8 watts. Now I'm going to switch to the fastest, which is the fifth gear, 1.44 amps, 17.8 watts, 1.42 amps, 17.9 watts, 18 watts, 18.1 watts, 18.0, 18.2, 1.46 amps. Okay, so that's the that's what you see here. 14.8 amp, 1.49, 1.48, 1.46, 1.45 amps, 18 watts. You see how little current this big motor is drawing when it's in the air. It's only not even 2 amps this big motor is drawing out, versus the Minn Kota 30 pounds, that other small trolling motor I have. This is burning 18 watts. Here we go. So I just turned it into active neutral, so everything is pulled. I now have a 24 volts system here, and because each battery is 12.7, and that's why the two combined is about 25.45. Is about 30 watts or amps, because I haven't turned my radio dial yet. Diagram here. So the negative is to the shunt of the first battery, and then I'm trying to show you how I connected it to make it 24 volts. And the positive of the first battery is linking by this black wire to, keep in mind, this is positive of the positive terminal of the first battery. I'm using a negative black wire to connect to the negative of the second battery. Okay, so that's the design or connection here. So that's the negative. And then I'm using my shunt, connecting my shunt, or the LCD display positive, to the second battery positive terminal, as well as the PWM positive battery to positive terminal to the second battery positive terminal. So this way, essentially, you are connecting to form a 24 volt system. Okay, so now I got two batteries connected. You can see. So now I'm just going to turn my voltage, my trolling motor. Hear that? That light is on. That blade is slowly turning. Okay, hear that? So now it's running on the 24 volt system. The PWM red light is lit, solid, meaning right now it's controlling the motor. As you can see, that's a 24 volts. Okay, so I'm gonna increase my speed to the maximum. Whoa, you see, that's really fast, you know, and it's throwing more amperage than 12 volts system. Alright, the motor guide is humming big time as well. I don't hear anything from the PWM, okay, and I do hear a lot of humming noise from that trolling motor. Okay, and right now it's flowing 2.42 amps and using 60 watts. Okay, and that's the motor guide. 24 under the 70 pounds, 24 volts, 7 amps right now. Okay, I don't know if you remember when I used the 30 pounds minn kota, the smaller trolling motor, the amperage at the maximum speed was actually drawing 3 amps. It's actually drawing more amps and about 60 watts. Same thing for the maximum. Or actually, it's drawing more watts. It's 150 some watts for my 30 pounds trolling motor. So this motor guy is actually, with the 24 volts, is actually more energy saving. As you can see, it's only at the maximum speed of maximum speed 5. It's actually drawing 2.4 amps only, and it's burning 60 watts. You know, so the energy is only burning 32. So the motor guy, the bigger motor, so they're saying the bigger motor is actually more efficient in the water. And again, if I put this thing in the water, it's going to draw, you know, some amps, but it's very efficient because it's a bigger motor. You know, it's right now it's 57. That's it. So I'm showing you this, okay? 2.2 amps, 24.8, 54 watts. It actually dropped from a few seconds ago. You know, it's now 2.22 amps. Alright, so that's my 24 volt system. As you can see there, drawing 55 watts, 2.22 amps. Okay, so that's my experiment for 24 volts motor guide. No load, meaning not in the water, you know. So I'm gonna hopefully disassemble this, or actually take it into the water, mount it onto my boat, take it out in the water, and show you guys. Okay. Anyway, anything is now portable because everything is portable because I put everything, both the meter and the PWM, onto this board, you know, so I can carry them. Okay. So that's my motor guide, trolling motor, no load, controlled by the PWM. Okay. Anyhow, this is the PWM, but I'm going to do something in connecting my 24 volts trolling motor to the battery, and run it without the PWM control, and just connect to this digital display and see what happened there. Okay. So I'll show you that in a second. But you can see the motor is humming big time fast. You see, I can control this blade so that, you know, before you can't even, now you can see the blade turning, you know. It's only drawing 0.19 amps. Yeah, this is going to help when I'm in the calm water, when I don't want the first speed, you know. And that's like 0.2 amps, you know. Now, let's stop. Okay, so that was testing. So now I'm going to do away with this PWM, just connect to the display and show you how many volts this trolling motor is going to draw from the fixed first gear, second gear, third gear, fourth gear, and fifth gear, and see how many amps this motor is drawing without the PWM regulator. Okay, sorry, I messed up the connection before when I removed the PWM's wire. I forgot to disconnect the PWM positive and negative to the battery. I only disconnected the battery, the motors positive and negative, but I forgot to disconnect these. So now everything from the PWM is totally removed from the system. So let me repeat system connection. Let me tell you what the correct system should be. Okay, so now this red wire again is from the trolling motor to the second battery, and this green wire is the display positive power wire to the second battery positive. Okay, so this is to the trolling motor positive wire, this is to the display positive power, providing the display power, and then the negative of the display is going to the shunt, from the shunt and back to the first battery negative terminal. And we have from the first battery positive terminal out when this black wire, and the black wire is actually looping around to here, back to the second battery negative terminal, and that forms a circuit. So now I'm going to turn my motor, okay, from the first gear and so forth. Now pay attention to that display. So that's the first gear. As you can see, all of a sudden the amperage just jumped from 0 amps to 1.7 amps, 1.76, 1.77 amps, and the watts are 44 watts right now. This is the first gear. It's burning 44 watts and drawing 1.75 amps. Okay, so that's my motor guide without water. So it's drawing 1.3 amps right now. 43 watts, burning 43 watts. That's the first gear. Okay, and let me move on to the second gear. This is the second gear. It's drawing 1.79 amps, burning 44.6 watts. 1.79 amps. And this is the third gear. Still drawing about 1.77 amps and burning 44 watts. This is because I'm not in the water, and that's why the motor is drawing about the same amount of current. But if I'm in the water, putting this motor under load, then the third gear is going to draw a lot more than just 1.86 amp. You can see that blade is actually fanning the plastic bags in the back, so it's actually pretty powerful. And right now, this is the fourth gear. Fourth gear, it's still drawing about 1.77 amps, burning 44.0 watts. Okay, 1.77 amps. This is the fifth gear. Fifth gear, and it's burning about 1.79, 1.8 amps, burning only 44 watts. Unlike the 30-pound minn kota trolling motor, this motor guide is burning less wattage than that 30-pound 12-volt system. So this motor guide is actually very efficient with 24-volt batteries, and it's only drawing 1.7 amps, burning 43 watts. It's amazing. So this is neutral. Okay, so that's it. You see, all of a sudden the 1.79 volt amps drop down to zero. And it is amazing. It's without that variable speed control, the PWM on the left here, that motor is just going to draw so much DC current from 0 to 1.79 amps. So I guess 24 volts for this motor doesn't need to be regulated by the PWM. So I guess the PWM, from this experiment, the PWM probably will be more beneficial for the smaller trolling motor, which creates and draws a lot more amperage from the smaller trolling motor. Again, I'm not putting this into water, putting the motor under load in the water. So the real test will have to come when I put this big trolling motor into the water and see how, when it's really in the water and under load, to see what kind of thing I get. Okay, anyhow, so that's it. Thanks for watching.